Okay, so I will start in 2-3 minutes. Let's wait if any others join. So, Nikhil, is my screen visible? Okay, so I think I should get started. So for those who are joining late, I am just recording the lecture and it will be uploaded after completion of this lecture uh, within 2 or 3 hours, I think. That is the today's time. So, welcome to week 6, where the topic basically covered was about LR parsers and all types of LR parsers, where uh, in the lectures we saw about LR0, then LR1, which we say CLR1. So then SLR1 and LALR1. So I will first introduce about these parsers a little bit, and then we will go for some of the problems, and then we will solve some previous year questions because they are very few, and there were some repeated questions, so I had to left. So let's get started. Is my screen visible? Can anyone confirm? Please comment. If not, please comment. Otherwise, I think it's visible. Okay. So okay. So a little bit about the LR parsers. Okay. So first thing is these are actually the most efficient method of bottom-up parsing, and we can use it to parse large class of context-free grammars. So if I write, it is actually bottom-up parsing, and used for context-free grammar. That is one thing. Then we also tell it as LRK grammar, LRK parsing, sorry, where where uh, L actually stands for left to right scanning. Okay, left to right scanning. Then the second thing is R. R actually stands for rightmost derivation in reverse. And third thing is K. So K is actually number of input symbol when K is omitted and K is assumed to be 1. Okay, or we can say it as look ahead. Uh, so number of input symbols when K is omitted and K is actually assumed to be 1 by default. So these are something about basics of LR parsers. Then there are some properties, that is if we say LR parsers can be constructed to recognize most of the programming languages for which context-free grammar can be written, and also the class of grammar that can be parsed by LR parser is actually a superset of the grammars that can be parsed by using predictive parser. Okay, so two things. First is it is used to recognize uh, the programming languages for which CFG is used, that is context-free grammar, and second thing is it is using the superset of class of grammars that can be parsed using predictive parser. Okay, then uh, it actually works using non-backtracking shift reduce technique. Okay, so we don't have to backtrack and we have to use shift reduce. So a little bit about its structure is actually shown in PPT, but for the sake of perfection, I am just so that you may recall it easily. So consider it is the LR parser. So we will have three things with this. First is the input buffer. Okay, input buffer where we have a, consider there is a string, and at the end of a string we will have end of a string symbol, that is dollar. Okay, so one thing is this. Second thing is a stack for shift reduce operation. So on top of a stack there will be the initial symbol. Okay, that will be pointed by this, and at the bottom of the stack there is dollar. Then there is a parsing table which we create with the help of the logic what we use, and there will be two things. One is action and there is go to. Okay, that will let us see, and it starts from S0 means the first state, and using these three we actually provide the output whether this the string or the things can be accepted or not by that parser. Okay, so the input buffer is used for input string. A stack actually uses the grammar symbols, and the parsing table has action and go. Okay, so it is in taking input string. This is storing the grammar symbols, and the parsing table actually is used for the uh, logic behind the parsing, or we can say there are some actions and go to. Okay, then also it reads uh, input symbol one at a time. Okay, from the input buffer. Okay, so input symbol one at a time. Okay, that's done. Then how this algorithm works? So first actually it initializes the stack with the start symbol and invokes the scanner, or we can say the lexical analyzer, okay, to get the next token. Okay, so we started with the start symbol as we have seen here, this, and we invoke the lexical analyzer, and uh, then we actually see what is the state on the top of stack, and actually the symbol that is on the input string, input buffer. So we actually see these two, and based upon this we consult the parsing table for the action. We can say like there is action something like sj, and there is ai. Okay, so on top of stack what is there, and on the buffer what is there. Based upon that we actually shift or reduce. Okay, so if I say si, uh, then I want to say shift to state I. Okay, shift to state I, and if I am writing rj, so that is by reduce by rule j. What is rule, what is state, that is covered in the ppt, and also I will tell. Okay, then there is third thing, that is first action, second action, third, means not actions actually, we can say it values. Okay, so in parsing table we have four kind of values. Okay, so first is si, means shift state I, then rj means we want to reduce by rule j, then there is accept, and for 4 there is error. So there may be error entries, and if successful parsing is done, then we will say it as accept. Okay, so these are something, and then there are four types of lr parsers. Okay, so there are four types. So first is lr0, slr1, clr1, then lalr1. Okay, so slr means simple lr, clr means canonical lr, then lalr means look ahead lr. Okay, then there are some other things we should know, that if a grammar is lr grammar, then the grammar should be unambiguous. Okay, so we can note it, you can note it like if a grammar is lr grammar, then the grammar should be unambiguous. That is one thing. Then uh, vice versa is not true. Okay, that may not be for converse. Okay, uh, or we can write it, but converse need not to be true. That may be, may not be true. Then For LR parsers, the parsing algorithm is some, but parsing table is different. Okay, so the parsing table, sorry, parsing algorithm is same, but parsing table is different. Okay, so now coming to the LR parsing algorithm. So let's consider X is actually uh, state on top of stack, state on top of stack. Then consider A as can say look ahead symbol. Then um, there may four things happen. First thing is, if action of small action of x comma a is si, then we will shift a and I into stack and increment the input pointer. Okay, then shift a and I into the stack and increment the input pointer. Then second thing what we can do, if action x and a is r of j, then uh, if jth production is can write it as if jth production, we will number the productions. Okay, production is alpha derives beta, then we have to pop 2 into mod of beta symbols and replace by alpha. Okay, and if s minus 1 we can say state is below alpha, then we have to push go to just if you are not able to think in this way, after this I am taking the example. So if there is some state Sm and Sm minus 1 is the state below alpha, then push go to of Sm minus 1 and alpha. Then third what we can do, we can if action of x and a is accept, then we can say it's completion of parsing. And the fourth thing, is if it is blank, then there will be error. So these four things can happen. Now consider one example. Uh, Consider there is a grammar of like this: AA, then A derives small a, capital A, or B. Okay, and we are given a string W is equal to A, B, B, and then end of a string. So what we have to do, we have to apply LR parsing algorithm on the following grammar, on this grammar. Okay, we have to apply LR0. Okay, so let's apply it. So what we can do, we can go like first we have to create the transitions, and then we have to go for transition table, we can say parsing table, and based upon that we will use push and pop operations. Okay, so just a minute. Okay, so what we do first, we first create the augmented grammar. It is actually given in the PPT. It is actually covered in the lectures with different examples. I am taking a simple one. So let's consider we are just providing some numbers to these productions first, because we will use it. We have actually three productions by default. So we say it as production 1, production 2, and production 3. Okay, now we have to augment this grammar. So first S dash provides S, then S provides A, then A provides small a, capital A, or B. That is done. That is the augmented grammar. So what we have to do, we have to start with this symbol, and we have to go forward. We have to put a pointer between the before the right hand side. So uh, there is S dash. We have to start, and we have provided a pointer before S. Okay. Now what we have to do, we have to take the closure of that non-terminal uh, of which before which we are actually uh, put the pointer. Okay, so here the pointer is before this, or dot is before this S. So what we have to do, we have to take the closure of S, means if there is S, we have to go to its production, like this this is the production, and we have to actually write it with this production. So what we will write, S derives AA, and we will put the pointer here. Now as capital A is also a terminal, so we have to put the production of capital A also here to take the closure of this one. So small a, capital A, and A derives B. So this is actually our state 0 and we can write it as I0. There are no restrictions on writing the names, but generally we represent it as I. Now we have to move our pointer one by one on uh, each of the terminal and non-terminal. Okay, so starting with the first production, we have capital S after the pointer. So if we will move, if we will parse capital S, so what we will get, the pointer will actually where which production we can use for parsing, only the first production, that is S dash derives dot S. And after parsing this one, what we have to do, we will we will move the pointer after that symbol. Okay, simply we have to put the pointer after that symbol. So we have taken S, now the pointer will point after S. After this, if there is something after that pointer, then we will take closure of that terminal or non-terminal, what symbol is there, based upon that. And if there is nothing, then it is done. And also there is no other production which is actually using S on right hand side, and that is after that pointer. So this is the only state where we can land. We just name it as I1. Okay, now from second production, what we can get, there is A. So on capital A, which production will work? If we see, there is only one production, that is second one, where we have capital A just after the pointer. Okay, so we will actually move the pointer from that capital A. So first capital A and then pointer, then second capital A. Now we have to take the closure of the uh, non-terminal productions, which is actually after that pointer. So if we see, there is a pointer after this before this A, so we will take that closure of this A, means we have to take the closure of A. So if we will take closure of A, what we will get, we will get two productions. First is A derives small a capital A, then A derives B. Okay, now coming to the next production, there is this one. So the dot is before a terminal, and also in second A derives dot B, there is also dot before the terminal. So terminal has no productions, so this state is complete. We can write it as I2. Okay, now the second production is done, this is done, this is done. Now coming to this one, what we will get, if we will parse this small a, so the pointer will move towards capital A. So A derives small a dot capital A. Then what will happen, we have to take closure of this A. We have to take closure of this A. So closure, with the help of closure, what we will get, we will get dot AA and dot B. Again, if we will see, there is there is terminal A after the dot, and there is terminal B after dot. So this actually this state is done. We can say it as I3. Okay, now the fourth one, there is this B. So these three are done. This B. On B, what we will do, we have only one production, that is fourth one, A derives B, and we have taken B into our consideration, so we will take it as B dot. Okay, So now we can write it as I4. Done. So these are four states. First layer is done. Now coming to the derived states, I1, I2, I3 and I4. In I1 there is nothing after dot, so that is actually finished. We don't have to move further. In I2 there are three productions and all have something after that pointer or dot. So we have to move one by one. We have to move our pointer one by one and see which state it will lie, or we have to create a new state or not. So starting with the second state's first production as derives a dot a, if we will parse a from here, so in these three productions of I2 only the production updated will be the first one, because there is no other production which has dot a after um uh, means there is no other production which has a after dot. Okay, so we will land at a dot. Now there is nothing after this dot, so we don't have to take closure of anything. The state is done. We can write it as I5. Now coming to the next one, if we will use a, if we will parse a, what we will get? We will get this a derives small a dot a. Now we have to take the closure of this a. It will provide us a small a, and it will provide us this also. And if we see carefully, this is actually the same state I3. Okay, so we can actually move it to I3. I can rough it. I can just write I3 here. You can put the arrow to I3 also, but we don't know how much we have to go in depth, so just I3. Okay, this is done. Now coming to the next one, if we parse b from here, we will get a derives b dot, and if we see it clearly, it is actually I4. Okay, so that is done. Now coming to the next one, I2 is done. Coming to I3, if we will parse capital A from here, so on capital A, where it will go, it will actually uh, only first production which will use it, because there is no other production which has a after dot. Okay, so that is done. We can say it as I6, and if we parse small a from here, we will ultimately land in a state this only, or we can say I3 only. You can check, and from this, from B, we will land at I4 only. Okay, so this is actually the transition map we have created. Now we have to create the parsing table based upon this diagram. Okay, so in this diagram, how we have to create this action and go to, let's use the another page. So we have 6 states here. Okay, so we have to create a table like there should be three things: action, there should be go to, and there should be some states, or we can say you can write it from 0, 1, 2, 3, 4, 5 and 6. Oh, I have forgotten. We have to write the symbols also. A, then B, then dollar, then there is S, there is A. Okay. Now based upon this transition diagram, we have to fill this table. Okay. So try this. Okay. So first I have to see on 0, state 0, if we see A, the terminal A where we will land. Okay. So on state 0, if we see terminal small a, we are going to this I3. Okay. So what we are doing, actually we are shifting at from state 0 to 3, or we can say S3. Okay. So on taking any terminal, we will shift the state. In action we will shift, and if we will get any non-terminal, we will go to some state. Okay. Now there is state 0 and small b. 0 on b, we are going to I4. So shift 4 here. Okay. Then on dollar there is nothing. On dollar there is nothing. On S we are going to I1. So we can write go to 1. And on A we are going to I2. So we will just write the state number 2. Okay. Likewise, we will fill the overall table. Now there is state 1. On any other symbol we are not going anywhere, so it is actually the first symbol, starting symbol. So on getting dollar, we write accept, means we have clearly passed the string. Then if we are at state 2 on A and B, we are on state 2, and on A we are going to I3, on B we are going to I4. So we will write S3, S4, and on capital A we are going to I5, so we will write 5 here. Now coming to 3, state number 3 on capital A we are going to 6, on small a we are going to 3, and small b we are going to 4. So S3, S4, and here will be 6. Okay. Now coming to state number 4. On state 4, it is not going anywhere. It is actually end of the production, and what production it is using? It is using production number 3, A derives B. Okay. So we will write the reduce on each of the string, each of the means terminal, using rule number 3, reduce using rule number 3. Then at 5 State 5 is there, and state 5 is actually using rule number 1. Okay, so R1, R1, R1. Then for 6, it is using this rule 2, using 2, R2, R2, R2. Okay, so all the states, all the actions and go to is done. So it is actually a LR0 parsing table. So we have this parsing table now, and we have to parse our string. Okay, we have to parse our string, that is AABB. We will put a dollar as end of string symbol. Now, how we will solve it? How we will parse it? We have the stack. We can use table also, that is taught in the lectures, but I think it will be better if I go in a diagram form using stack. So consider there is a stack. On top of it we have this zeroth state, and on buffer we have AABB star. Our pointer is that initial word of this string. Okay, sorry. So now we have to see, that's why we will see the action 0 and A. Okay, 0 and A. Why? Because state X is actually 0 and symbol A is A. What I have told in this rules, XA, action X. Okay, so X is state, that is on top of a stack. Now this is a stack, and we have a small a. So we have to see the action of 0 comma A. So on 0 and A, where we are going, on 0 and A we are using S3. Okay, so that is S3, means we have to shift A and 3 into the stack and increment the pointer. What I am telling, shift A and 3 into the stack and increment the input pointer. Okay, that is one thing. So just put it, what we have got, say it is step 1, step 2, where we are going, we are at A, then 3 on top of stack, and we have advanced our pointer to second A. Okay, now again what will be there, we have to see the action on this top of stack, that is 3 and A. What is there, 3 and A, we have S3. So what we will do, we will actually put the string on the stack, 0 A3 A3. Done. Top of stack is now 3, and we are at B now. Okay, now there is action 3 and B. Action 3 on B, we are going for S4. Okay, so just put it, we are at 4th time, we have 0, A3, A3, B and 4. Okay, now it's done. Now our pointer is at A, B and second B and other. Now what we have to see, top of stack is this 4, top of stack is 4 and there is B on input string. So 4 and there is B. So what we are doing, we have to reduce R3. So what we will do from here, just come here. What we will do, we have to pop actually 2 into beta, or we can say there is one symbol, so 2 into 1, actually 2 symbols we will pop out and replace. So what we will do, we will just pop out this 4, this B, okay, and we will put the symbol, okay. There is go to what we will do, we will actually at R3. So we have 2 symbols and we have to replace it by A, capital A, and we have to also push the go to of 3 and A. Okay, so what we have on this 3A, 3A, then on top of it we have A, and we have to actually write the means there is rule 3, so 3 and A we have to push go to 3 and A, so that is actually 6, we have pushed 6 in. Now top of stack is 6 and on input string we have actually this B on A B B dot. Okay, now we have this stage 0 3 A 3 A. Oh, so we are at 0 A 3 A 3. So this is A 3 A 3. There is A, there is 6. So we are at this one, and we have A dollar. We have this one. Now we have to see for action 6 and B. What we will get? Action 6 on B we have R2. Okay. So R2 is rule 2. Rule 2 is actually this one. So what we will do, we will actually again in R2 rule is AA. So total length of string is 2, so we will pop out 2 cross 2 means 4 symbols. Okay, so we will pop out 4 symbols from this to this one. Okay, so what we have got 0 A3A from here. All four are popped out. Then we will push the symbol with this A, push this symbol A, and also we will push that again I have done some mistake, I think. Yeah, A is also gone now. So we have to go to A3 and A. Go to this 3A. Okay. So on 3A, we have seen earlier there is 6. So we will push 6 also. Go to 3 and A. We'll push it here. Now top of the stack is this 6, and we have on a string AABB dollar. Okay. Now again on 6B, what we will get action 6B again. There is R2. Again we will pop out 2 cross 2 symbols. So 4 symbols we have to pop out. Okay. So we are here with only 0. And what we will push that A on top of it and go to of A and 0. Go to 0 and A. Sorry. So go to 0, and A is actually 2. So we will push 2 here. Now top of stack is 2, and we have again AABB dollar. Okay. So what we will do, we will see for action. There is 2 and B. Action 2 and B. We have to S4. Okay. So we have to push the symbols. Okay. So what we will get? 0, A, 2, B, 4. Now we are here. 4 is here, and we have to advance the pointer A, B, B, and we are now at dollar. Okay. So overall string is done. We have dollar at the end of string for finishing of the things. Now what we have to see, action 4 and dollar. Just see, there is 4 on dollar, there is R3. Okay, so R3 is there. We have to reduce, means using rule 3. So rule 3 is actually this one. We have only one symbol at the right hand side, so we will pop out 2 symbols. 2 into 1, total 2 symbols we have to pop out. So we will pop out this 4B. Okay, so where we will go, we will be at 0A 2B. Now we have to push the A here, 0A 2B. B is gone, 2 symbols, B is gone. We will put A here and go to of A and 2. Go to of A and 2. I think we have used it earlier. 2 and A, sorry. Go to of 2 and A. No, I haven't used. Go to of 2 and A is actually 5. So we will put 5 on top of it. Now what we will do, we will see the we have forgotten number 4. This is 5th, 6th, 7th, this is 8th, then 9th, then at 10th step. We are here. Now, coming to the 11th step, we are at 11th step. We have action of 5 and dollar. Action of 5 and dollar, we have this R1. Okay, so that is R1, means we have to pop out using first this one, this S derives AA. Okay, so there are two symbols, so we have to pop out four symbols, 1, 2, 3 and then 4. So we are left with only 0, and we have to put S here, and we have to see for go to 0 and S. So 0 and S, we have 1. So we will put 1 on top of it, and our string is remained here at this one, dollar. So now we have to proceed for action uh, 1 and dollar. So on 1 and dollar, it is actually accept. Okay, that is accept. So we are actually parsed. So successful parsing, we can say. So in this way, we actually use the stack and parsing technique of LR0. Okay, again I am just briefing it what we have done. So there are 4 rules. First is if there is some look ahead symbol XA, means what we are looking ahead, we will if there is terminal or non-terminal, we will use uh, that one for our next action. We can say S or R. S is shift and R is actually reduce. So if we will shift, if there is shift action on parsing table, we will shift both A and I, means the input symbol and the state where we are going. Then if we are reducing, then we have to uh, see which rule it is using. So if it is using this alpha derives beta, so beta is actually of one symbol only. So we will pop out 2 into 1 symbol, means 2 symbols from the stack, and replace it by alpha, where we are actually deriving from where we are deriving beta. And also we will push go to of SM minus 1 and alpha, means if there is a state 0 on top of stack and on top of it we have pushed alpha, so alpha and just the state just below the alpha we will take go to of it, and we will push on the stack. And if XA is accept, then it is complete, otherwise if it is blank, then we will have some error. Okay, so in this way we will use the algorithm. Now we have to create a transition diagram and the parsing table. So how we will use it? We have provided some numbers to the productions like 1, 2, 3 for each of the production, and then we will create a augmented grammar. In augmented grammar, we will just add a small variable like s which derives the starting symbol. Now what we will do? We will actually take the pointer which will point at the starting of the start symbol, and based upon if there is terminal or non-terminal, we will take the closure. if there is closure means if there is any non-terminal before after that pointer, we will take all the production of that non-terminal in this and consider this those terminals in that state. So like in first state I0, we start with the starting symbol s dash derives dot s. So pointer is before s. So we will just take the closure of capital S and we will put all the derivations of which are using actually which have s in left hand side. Okay, so we have actually this only this s derives a there, so we will put s derives a and there will be the pointer before first state. Then we will again take closure and we will take those closure till we get any terminal. So we have taken the closure of s derives dot capital A capital A. So capital A will have derivations dot small a capital A and small b. So these two are actually terminals. So we don't have to further take closure of any of the non-terminals in this state, and this state is completed. We have provided some name I0. Now we will take a look ahead, or we can say a single symbol on parsing of which we will land to some another state. So we have taken one by one. First is S. If we will take S, we will advance the pointer after S and we will provide some state name, say I1, and there is nothing, no symbol after that dot, so our parsing is done. Similarly, for A, for small a, for small b, we have created this transition diagram. Now we have this transition diagram, we will have to create the parsing table. So parsing table, what we have to see, if we are at some state, say state 0, on other symbols, on taking different look aheads, where we will land. So on taking S, on taking A, on taking small a and on taking small b. So on taking S, we are going to 1. Okay, so we will write at go to 1. Similarly for state 2, capital A, we are going to state 2, so we will write at go to. So each transition on non-terminal we will fill entry in go to, and each transition using any terminal we will write shift entries. So we actually shifted to third means I3 and I4 on getting small a and small b. And also if that if we are not going anywhere, say in I4 there is no outgoing edge and this production is completed actually, a there is b dot, so we will reduce. How reduce? We will take the uh, production number or rule, we can say, like a derives b is, we have provided number 3, so using rule number 3 we will reduce. So that we have written here on 4 we have R3 on each of the terminals. Okay, so that is rule we have followed. And now what we will do, we will take the string we have to parse, we will push and pop based upon the rules we have provided. So in this way we actually parse the symbol. Okay, now there is a little difference between this parsing and when we use that the next parsing, that is SLR1. So in SLR1 we actually take the uh, follow of the symbols. Okay, follow of that what we say uh, follow of that non-terminal for reduce entries, for reduction. Okay, so I will take some example after some time. Let's do some questions for the LR0 first. So now we are done with how we derived the symbol table and how we actually parse it. So one more thing, if there is only one entry per cell, then only the uh, grammar is actually parsable. Otherwise, if there are more than one entry in each of the cell, in these cells, 0A, 0B, if there is only one entry, then we can say it is parsable. Otherwise, we can't parse any grammar. Okay. So now I'm taking some questions. Um, we have to check for this, it is LR0 or not. LR0 or not. We have to check for the cells. If there is more than one entry in any of the cells, then there is no LR. So there is S derives this, L derives. So there are four rules. Okay, there are four rules. Say this is first, this is second, this is third, this is fourth. Now first we will create the augmented grammar. S derives S and S derives L or A. L derives L, comma S or so. Let's start creating the diagram. First is S derives S, and before that we will put a pointer. So from pointer we have to take the closure of S. So what we will get? S derives L and S derives dot. Okay, so this is actually our I0. Now we have three symbols: capital S, then open bracket and small a. So this is I1. Now we have this open bracket. Now for this dot is before L, so we have to take closure of capital L. So closure of capital L will provide me two productions, that is L derives dot L comma S and L derives dot S. Okay. Now from this dot L we have already taken closure of L, so it is done. From dot S we have to take closure of capital S also, So we have to consider production of capital S also. So there is dot L and S derives small. Okay. So this is, you can say, I2. Now coming to small a. Small a will provide S derives A dot. So this is I3. Now first layer is done. On the second one, what we will get if we use capital L, if we pass capital L, if I look ahead is capital L, where we will go. Just see the productions which have capital L after this dot. We have actually two, this one and this one. So these two will advance your point. So S derives L dot and L derives L dot comma S. Say this is I4. Okay. Then the next one, L is done. Now there is S. So L derive S dot. There is nothing after that dot. So this is actually completed state. I5. Now there is the open bracket. So after open bracket, there is only one symbol, that is this this one. So what we will get? We will get actually S derives dot L, this one, and this will actually take closure of L. L will take closure of S. So ultimately we will land up to this production only. This production only. Okay, so we can just erase it. So on open bracket, we are going to same one, and there is small a. So on small a, you can see we can go there on S derives A dot. Okay, so this is something. Now two layers are done. On third one we have I4, I5 and I6. I5, I5 no, there is no I6. So I5 is done. So we have only I4 here. So on close bracket we have S derives, and it is done actually. So we can say it as I6. Now from here, if we go to this comma, so we will actually take only this production L dot L comma then dot then S. Now S, for S we have to take the closure. So S derives L and S derives dot A, and this will be another state. We can say it as I7. So again, if we will see, if we will just parse capital S, then we will go to L derives L comma S dot. That will be a final state. So we can rename it. And if we will just parse the open bracket, then if we will see, we will go to I3 again. we will go to I3 from here, and from A we will go to sorry, we will go to I2 from here, and from A we will go to I3. Now, so this is done. I think there is no other symbol left. Now we have to create the table. So we have action, and then there is both. There is states. Okay, so we have actually total 0 to 8 means 9 states. So I think this will not cover overall. So let's create a table. There should be states, there should be action, there is photo. So there are some terminals. 0, 1, 2, 5, 6, 7, then 8. Okay, so let's fill it. How I will fill it? Um, this is a diagram. So from 0th state, if we see, there are 3 transitions. On S we are going to I1, so there will be 1 on S. On open bracket there is 2, so there will be shift to 2, and on A we are going to 3, so there will be shift to 3. So 1 S2, so this is one thing. Now on state 1 there is the reduction using first one, using this augmentation rule, so that is actually take accept after it. Okay, then from I2 we are going on L, on S, on open bracket, and on capital A, small a. on L we are going to 4, on capital S we are going to 5, on open bracket we are going to 2 only, and on small a we are going to 3. So there will be 4, there will be 5, and on open bracket 2 only, and this 3. Okay, now next one, coming to the next state, there is 3. In I3 the production is done, there is no outgoing edge, so we will use rule number 3. Rule number 3, I think, no, rule number 2 is there. S derives A is actually rule number 2, so we will use R2 on each of the terminal. So I have R2, 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 R2. There is some wrong entry. I have to put it below this cell. So there is S2, S3, S2, and there is 5. Now there is state number 4. For state number 4, there are transitions on open bracket, sorry, close bracket. We are taking action for 6, we are shifting to 6, and on comma we are shifting to 7. So there will be S6 and S7. Okay, then on 5, it is actually the done. So L derives S dot is actually fourth production, fourth rule. You can see from here we will use reduction 4. So R4, 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 R4. Okay, now for 6th state there is this first one, rule number 1. This one is actually reducing, so R1, then from 7 we are going to there are 3 rules. First is on S, then A, then on open bracket. On open bracket it is shifting to 2, on A it is going to shifting to 3, and on S it is going to 8. So S3, S2, and on S it is going to 8. Then 8th state. 8th state is this one. So there is rule number 3. So R3, 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 R3. So is it LR grammar, LR0 grammar? Yes, because there is no any conflict in this table. So no conflict, no LR0 conflict. Okay, so this way it is LR0 grammar. Okay. So I think it's 8:25. Uh, I should take the previous year questions, then I will go to SLR1 questions. So there is a canonical set of items for LR0 parsing is given by S L dot is greater than R, comma QR dot on output symbol less than, the set has this shift reduce conflict, no. A reduce conflict, no. Both conflict, not possible, because it is actually done, so there is none of the options. Answer is D. In second question, there is a recovery in LR parsing may push uh, an input symbol into stack, state into stack, both input symbol and state into stack. None of these options. The answer is C. For error recovery, uh, LR parsing, we may push both. So in third, there is S derives B or SP SABS, B derives BB. So in state 0 for input A and B, what will follow? State 0 will contain this all the things. So on small a there will be an error entry and we will shift. Yes, because on small a there will be nothing. If we see from S dash derives S,
B.
so from here we have then S derives B, S A B S, then B derives B. This is I0. On A there is no transition, so there will be no entry, or we can say error entry. So A is the option, correct option. Then in sixth one, SLR parsing for the grammar state 0 A and B. So on state 0 it has derives E, E derives E, E. Oh, so it is written omitted only. Okay, so on A where we will go? On A we can go to this A E B E only, and on B we go to, and from E we have to take closer, which will take these only, and for B also. So actually both will have same instance and will have shift reduce conflict. If we will create the parsing table, we will get the shift reduce conflict, because we will there will be no choice for, there will be two choices for parser maybe. Then there is ninth question. In state 1 we have A derives A, beta derives delta A dot. First of A, follow of A and follow of B contains the symbol A. This will lead to, it is very simple, it will lead to actually reduce conflict. You can see from the PPTs, because if we will go to the look ahead, we will get two entries in the table. So as there is very less time we have, I have to cover more things. You can just create and check. I am taking one question for SLR1 also. So for SLR1, let me check. Uh, so first thing is, if grammar is LR0, then the grammar is SLR1 also, and if it is SLR1, then it may or may not be LR0. So this, keep this in your mind, and so just taking the first question only, what we have used, this one. Okay, so for shift, this one, for shift there will be same things, but for reduce, what will happen, uh, for SLR1 we will take follow of A and follow of S. Okay, so follow of A, say it is question 1. Follow of A, from here you can see there is nothing after A, so that is actually dollar, and follow of A is follow of S, that is also dollar. Okay, so we put the reduce move only on the follow of the symbol. So this is actually LR0 parsing table. Now coming to the SLR1 parsing table for question 1. So action move will be there. Likewise, S3, S4, and go to will be there. Likewise, 3, S4, 5, and 6, and then S3, S4. Now for reduce move, there are these much entries for reduction, but here we will put R3, R1 and R2 on the follow of these symbols. Okay, so R3 is actually uh, there for this A, so follow of A is dollar, and R2, here all the follows are dollar, so we will put all the entries in dollar only. So there is R3, R1, R2. So this is actually SLR1 parsing table for this question 1. So this way we actually create the SLR1 parsing table. Now something about LALR and CLR1. Let's talk about LR1 items. So LR1 item is actually LR0 items plus look ahead. Okay. So the general form of this is either A derives this alpha dot beta comma A, where A derives alpha beta is a production and A is a terminal uh, or right hand marker dollar, and we say it as look ahead. Now so LR1, what it actually refers? It actually refers the length of second argument. Okay. So this is actually production and this is actually look ahead. Now if the item is in form this one only, then look ahead can't have effect because we can't apply reduction. Okay, but if beta is say epsilon or empty string, then we call for reduction, and only if the next input symbol is A, or we can say look ahead. Okay, so to construct collection of valid LR1 items, we need two procedures. First is the closure, then go to. Closure is simple like previous, and go to is also like previous. We have to just calculate the uh, we can say look ahead carefully. So there are two cases. In case 1, there is in case 1 the symbol is like A, so we can't apply reduction. But if it is case 2, it derives alpha dot comma A, then reduce, but only if the next symbol is A, okay, or the look ahead. So let's see some example, just previous example only. Okay, so there is S derives A and A derives small a, capital A. So first is we have to create the augmented grammar S derives S. Now we have to construct the canonical set of LR1 items. So the diagram we were using, actually that is called the canonical sets. So of LR0 items, now we will create for LR1 item. So consider this first one, just derives S, and by default uh, we first take it as look ahead as a dollar. Okay, now we have to calculate for S derives dot a, sorry, A dot a and comma, there should be look ahead. to compute look ahead, we have to compare our this say production 1 with the previous this one. A derives alpha dot beta b comma a. So just compare these two, what we will get. So b here is actually s, beta is empty string, alpha is also empty string, then a is actually dollar, and capital A is sorry s dash, s dash. Okay, so first off, from here what we can see, first off this dollar will be the look ahead. So first of dollar is actually dollar. So s dash derives dot s comma dollar, and s derives dot a dollar. Now coming to the next one, there is a, so we have to take closure of a, so it will provide a and a derives dot b. Now what will be the look ahead? Look ahead will be first of a dollar, that is actually first of a, because first of a is not empty string here, so first of a will be a comma b. Okay, so there will be a or b, not both, a or b. Okay, that will be our first state, and likewise we will create the um, canonical set of or canonical collection of LR1 items. So from here there are two rules also for look ahead. Look ahead doesn't change when we make transitions, and look ahead may change when we compute closure. Okay, so on transition there is no change in look ahead, but in closure there will be change. That is one thing. Then what we say, uh, from here actually we can, let's create that diagram first. I have solution, I am just writing from solution using this rule only. You can create this canonical collection, so I am just creating it for you. We have to just see it and create the passing table based upon it. So I0 we have s dash derives dot s dollar, s we have dot a dollar, a we have dot a or b dot b, s0 1 s derives s dot dollar I1. So I am just copying it. So these are 9 states. Now from this we have to create the say this is example number 1. uh, Example 1 continued. We have to create the parsing table from here. So from there the shift move and say we have to create the CLR1 table. Okay. So what we can do, we have to just write this symbols A, B and dollars, then states I0. There are 9 I0 to I9 10 states, 2 I3 I4 I5 I6 7 I8 and I9. So now I have to see for this from I0 to where we are going. From I0 on S we are going to I1, from A we are going to I2, and from small a we are shifting to Y3, from small b we are shifting to 4, from I1 we have to accept, then we have to just move to the what other things we can do. We have to check for reductions because that is actually varying factor. So if we see state number 4, here we are reducing. This is actually done. So A derives B dot. A derives B dot is actually our production number, say 1, 2 and 3. So that is R3, and R3 will be done on this A and B only, not on all symbols. So R3 will be done on I4 on A and B only. Okay. Likewise, we will fill the other entries. So I am just writing. You can check by yourself. This is the correct answer. What I am writing. You have to go likewise. So this is the final table. What we will get after applying this CLR1. Okay. And for LALR1 we will see in next class, and there what we will do, uh, see for LALR1 I can just write, there is if there are different look aheads with same states, we actually put them into one state. Like here, um, in this, if you see state number 3 and 6, state number 3 and state number 6, both are actually same, but the look aheads are different. So we will actually combine the look ahead states. So for I3 and I6, what we will do, we will write it as I36 for both. Similarly, there is I4 and I7 also. We will write I47, and for I8, I9, we will write it as I89. So I am just writing the LLR table after this. We will have action, we will have go to and states. So A, B and dollar, S and A, 0, 1, 2, then we will be 3, 6. Instead of 3, there will be 3, 6, 4, there will be 4, 7, then there is 5, there is 6 is already done in 3, 6, 7 is already done in 4, 7, then there will have 8, 9, and 9 is also done with 8, 9. And the other entries will be likewise. And the reduce entry will be on A union B, means there are two states 3 and 6, so the reduce entry will be on uh, means shift and reduce all will be on A union B. So there will be S3, there was S4, so that will become 3, 6, 4, 7. There was accept, so that will be accept only. In go to there was no problem. In I2 there was similarly S3, S4, then 5. Now for 3, 6 there was S3, 4, 7, but there was reduced entry on 3, so there will be R3. Okay. Similarly, the reduce will be on A union B, means the entries on 4 and entries on 7, R3, then R1. There was 8, so that will become 8, 9, then R1, R2, sorry, R2, R2 and R2. One more thing, there is no 3, 6 because it is rule 3, not the state 3. Okay. So in this way, this is actually LALR0 table. Okay. CLR parsing table is bigger in size, and CLR1 parser actually reports error earlier than LLR1 because there is more scope for LALR. Sorry, blank entries. Okay, so thank you. That is all from my side. So today there were very less people joined. Uh, so this video will be uploaded, and if there is any confusion, you can write on discussion forum. So today my focus was to just provide a brief of all the things which was covered in lecture 6 or week 6, and what I have done is actually I have taken some examples, and based on that I have covered all the things. So uh, there were some questions in previous year, so this I have provided, so there are very less questions for previous year questions. So that is all done from my side. Thank you. And also so I have also covered the differences between all the LR parsers. So basically what we have to do in LR0 there was all kind of reducers we can use on every symbol. In SLR1 we will use the symbols when there is actually we can say follow of that left hand side symbol. Then there was CLR1. In CLR1 we actually use look ahead for the symbols, and LLR1 is actually where we will merge two of the states and create one state, and we will use that state. And in symbols we will write a union B, means symbols in state 1 and symbols in state 2, sorry, actions in state 1 and actions in state 2 will be there in the parsing table. So that's all from my side. Thank you. These things will be uploaded on the NPTEL lectures NPTEL folder, which is actually shared. And the recording will also be shared after some processing. And also if there is some doubt, you can use the discussion forum.